All right, here we are.
Hello.
Hello, everyone. Welcome to this new class of the Green Cheers Roadmap. Thank you, everyone, for joining. Thank you. We are getting live in the second class about acoustics. So, thank you, everyone, for being here. We are here, right? My name
Yes,
is
Yes,
we
we
are.
are
Philip.
here.
Yeah, we are all here.
We had an anxious night, but we are here.
Yeah.
Anxious
All
and
right,
busy night.
guys. You can go on.
Anxious, crazy night because we don't like to do things normal and calm and zen. We need that little shake, right, Felipe?
Yeah.
Yeah. Guys, once again, thank you for joining the second class of the Green Cheers Roadmap. I'm here with Sam and TC. My name is Philip, and we are going to start today talking about acoustics, the main strategies to handle acoustics on interior design. First thing that I wanted to tell is my apologies for people who hadn't received the summary on Instagram yet. Okay, what happened? We got 6 times more requests than we were expecting, and we were sending these messages throughout the day, right? But Instagram blocked us. Instagram blocked us. They didn't like that we were sharing sustainable things. So our DM, right, our direct messages are blocked. And I put
Damn
uh,
Zuko.
yeah, a notification on the news of the feed, right, on the Instagram. And what we are going to do, we are going to keep sending the summary for people who had requested it, but it will take a longer time. So what we are going to do, we are going to keep sending this, and I created an alternative link so you can get the summary for the first and second class at the same time. So in the end of the class, the link of the summary is going to be for both summaries, okay? So it's going to be by email. We are going to remove Instagram from this. It's going to be better for everyone. So you just need to go in the end of the class, get the password, and the password is going to be for first and second class. Okay. Just to mention it, we weren't expecting this amount of people, right? So we are getting blocked when we are sending this summaries for new people who are new in our Instagram. People who are already watching our previous events, they are getting the summaries without any problem.
Yes.
But people who aren't, Instagram find it strange. I don't know, maybe they don't know these people why they are sending summaries or something like it. But
They
it's going
were
to
like,
be
why
okay.
are you so interested in new green? No, block.
Yeah,
That
but
was that was it. It's personal, we know.
yeah, this is okay. It's a thing that can happen, but we are giving you alternative ways, and no one will leave this event without the summaries. We promise you this. Okay. Another thing is we are going to start this event talking about acoustical design. And of course, if you want to get the certificates, we are going to tell about this in the fourth day of the event. The certificate has a symbolic cost of $7. We talked about this in the previous class. So if you want to get the certificate, it's up to you to get in the fourth day. We are going to talk about this. Okay. So I think this is the
Felipe, because someone asked in the message, the certificate is for the whole event, right? Not each class.
yeah, the whole event. Yes, because it would
So
be
you
very
have to watch
crazy.
all classes.
Yeah, it's crazy enough to send one. Five, it would
Can
be
you
crazier.
imagine?
Yeah. All
Wow.
right, guys. So this is it. I think. Any more notifications or something? I think no, right? So
No,
we
I
can.
guess that was it. Oh, some people that did get the summary, they told me, or they sent us in the map. They said that they were unable to download it. If you get the message that you don't have authorization, try a different browser or perhaps check your firewall because most people did download. And another thing is the JPEG, it's only on the message to make the message illustrative. All right. When you download it, you're going to get a PDF file. All right. On the link. So that's it.
And
Yeah.
try it on computer, not the phone.
Yeah. Once again, about the summary, in the end of the class, you will have an email link to get the first and second summary. And we will be keeping sending on Instagram if Instagram allows us to send, okay? We will keep doing this. So, first day, biophilic design. This class is gone, right?
Yes.
This class is gone. People know about if people are into things, they know. Acoustics is going to be today. Wellness. The third day.
Tomorrow.
Tomorrow will be wellness.
Sustainable materials is going to be the fourth day. And lighting design is going to be the fifth day. Okay,
Don't
so
miss.
don't miss it. Once again, class for summary for class 1 and 2 will be sent by email. So we got you covered. In the end of the class, I will be sending you the link. Okay, no one will live without it. Okay, so let's proceed with acoustic design.
All right, guys. So let's create here a link. So the space we're talking about sustainable spaces. We're talking about features that will make this space sustainable. So I know most people are usually interested in materials, thinking this is the straightest way to think of a space as far as sustainability. But we have to look at the whole picture and we leave no one behind. And acoustics is usually the underdog, is the one that people, because acoustics is something so specific and something that requires you to study the space deeper, you will have to have a technician or at least understand well the basics of acoustics to create aids for these spaces to perform well. So you have to be careful when you are selecting the materials for these spaces, what kind of air quality that these materials of the acoustic panels or the acoustic walls will be providing here too, because certain materials, they can compromise indoor air quality, and I will talk to you about this a little further. And they will influence in the design of the space, but they will also help you save energy. So when we're talking about acoustics, if you quickly Google some studies and subjects, the late studies and subjects when it comes to noise pollution, this is our new stressful thing. We've been through air quality when air quality was something that was a very big concern to people and still is. But it's more, there are more people aware of how to deal with air quality nowadays. And the ball of the moment is acoustics, acoustic noise, because we are growing in population, we're growing, and the way we are living in spaces with more people and more cars in our traffic areas, we're also creating a louder environment. And this is the new thing that it's creating problems of stress and also cardiovascular problems too. So we have to be aware of how to deal with our spaces, how to promote better spaces dealing with acoustics. Just a moment here, because I think my WhatsApp, it's on and it's making a noise. Sorry. Okay. I hope you guys didn't hear that, but anyways. So I don't know, in your area, how do you feel about your area? How do you feel about the acoustics? Where are you at right now? Do you have noise interference? Do you have something that it's, that background noise that it's there and you don't know, but it's bothering you? Like that motor or that constant noise that perhaps can come from a fridge or something like that, that it creates a distraction and you don't even know. There's something there, but you don't know. And we're going to cover all these parts, all these areas here in this class. Yes, so many people saying here, I live in New York. Yes, Karen, I hear you. Never quiet in New York. Very noisy and crowded. Yes. So
can I add to your question?
Yes, absolutely.
What happens to you? Please answer in the chat. When you are in a place where you cannot understand the others, when it's the indoor noise is too loud, or maybe it's hard to understand, even though it's not that the intensity is not that high. What do you do in these situations, in your workplace, in a restaurant?
Yes. Here, some people say I have an upstairs neighbors with kid making constant noise. Yes, I can't relax properly because of traffic noise in Buenos Aires. So you guys are seeing here that are different things that are compromising your health. You can't relax, you can't sleep well, and just like light pollution that we will address in the coming days, the noise pollution, it's also something that can compromise our health. And it compromises our health in different ways because we start compensating for it. We're going to create things like we're going to sleep uncomfortable, but sometimes we're going to try to muffle our ears so we don't hear what's out there. Sometimes in a classroom, the teacher will need to speak louder, and therefore it's going to stress her vocal cords. In churches, they will start using sound systems. They were built to create that environment, that that environment where the sound has an effect, and it has that it's part of the intent of the church to have that sound, to have that type of acoustics, with the choir, it will sound good. But it also, when you are listening to the mass, or when you are in a different religion too, like when you are trying to listen to someone talking, they will have to use a sound systems to do that. Different things that can happen in smaller spaces too. If you have an office as an example, then you will try to hide, you will create sound masking, you start using headphones or anything that will try to create that microacoustic environment or comfort, like bring that comfort back to you. And usually those things will cost energy. They will cost either energy from you when you are trying to use your voice, or you're trying to concentrate harder. This is personal energy. And then you're going to use energy if you need to use sound systems, sound masking, and those things will have a cost, first of all, for the system, and it's not cheap. And also then the energy to run this system constantly. So working with acoustics is something that will bring health back to us and will also save energy and use it properly, right? So we have here in this class the objective here, and just like I mentioned, acoustics, they are something very complex. They are something that you need a technician to work if you have a more complex space. But if you are in a smaller space and you understand the basics of acoustics, you, as an interior design, have the power to bring many solutions to your client and help them create this comfort in this area. So first of all, we want the environment to perform accordingly to what was planned. So in a classroom, the teacher will have the power of using her voice at a normal tone, and the person in the front of the desk and the person in the back of the class will hear her and will hear it clearly. And also in an office, you will have places with privacy, or you will have a place where you have a meeting and you need people to hear you in a more in a bigger gathering of people, right? So poorly designed spaces, they can be bad if you don't think of the purpose of that area. And also you have the power to improve acoustics with beauty too. And we will see that the different elements that you can bring will also enhance the look of your environment. So this is a big part of dealing with acoustics. It's also selecting the right materials for the right purpose and using the beauty to not create ugly patches, let's say, to compromise your design. So we're going to try to show a little bit of both, the creativity and the basics of acoustics, so you can deal with this in your spaces. When we think of accessibility, right, we're talking about acoustics too, is to allow people to properly. It's part of the accessibility when you think of acoustics, and you're allowing people to properly understand you and hear you in any settings here. And acoustics become a very important too when you are in healing spaces. If you are in a hospital, you need peace and quiet for recover, and you need to have this certain control. So this is also something important. But along with this, we have many things. When we talk about accessibility, we're talking about physical ergonomics, we're talking about visual, that we will cover daylight and artificial light, indoor air quality, and materials health, everything that become, and the biophilic design that we covered yesterday. So this kind of like encompasses what we are elements that we can touch, and they are also part of sustainability. It's important to look at sustainability in a broader way and access every aspect of it in the right way, thinking about materials, health, accessibility, and environment, and like creating this aura around your decisions. You will fulfill your sustainability efforts. So with that, I will allow Tissi to start here, showing you some basic concepts of sustainability, and I hope you guys enjoy this class.
We're not going we're talking deeply about acoustics today, but we are not going to talk about everything. We are going to concentrate on those sound properties that we have to remember from architecture school or from interior design school, just to make sure that we start on the same basis here. Okay. So we are going only to talk about reflection and absorption, because those are the most frequent and sound properties that the interior designing will deal with. Okay, so reflection, that happens when sound reaches a surface that is very smooth with low porosity, and then it will reflect in the same angle as it reached, theoretically, with the same angle as it reached that surface. Okay, and when it does, it reinforces the sound intensity. So when you have, for example, polished stone, which is very common in historical buildings, for example. The sound usually is higher because it's so smooth that the sound will reflect easier, and then it gets more intense. Another thing that is important to remember is that to lose intensity, one way is to have a distance. So when you have high volumes, usually people have reflective materials so they can reinforce that sound so it doesn't lose intensity in that wide room, okay? And then we have a very important concept that we are going to deal with today, which is reverberation time. Reverberation time is, as it says, a time span, okay? So we count it in seconds, which is the time that the sound needs to lose 60 decibels. So when there is a certain level, and then we count, okay, how many seconds it will take to lose intensity up to 60 decibels. And then we have the reverberation time, okay? So when there is a lot of reflection, this time will be longer because there is sound intensity, and this sound intensity is being reinforced by those reflections. And then the sound will stay longer in that area. We are going to show you examples of that and the difference in a minute, okay? So the perception of people in these environments is not only the direct sound. So, for example, if you are hearing me in, as Sammy said, in a church that is made of polished stone, you're going to hear my voice directly, but also all the reflections that comes from it, okay? And then it will sound like my voice will last longer, and sometimes it can prevent people from understanding what I'm saying because it just gets really confusing, okay?
It's like the priest, right?
Yeah.
It's like the priests in Catholic churches, right? When they say, we are going to start this, how it's misa in English?
Mass?
Sorry?
Sorry, I was on mute. Mass. It's a mass.
Okay.
It's a different mass, but it's a mass.
Okay. We are going to start, everyone sit down, or something like it. Very bad, I'm sorry, but I'm trying. Okay, you can proceed.
Okay, so it depends on the room volume and also the finishing properties. And this is why we are talking about it here, because interior design is all about, it's pretty much, no, that's not right to say, but it deals a lot with finishing products. Okay, so there's a lot of things involved, but one of the important areas is also finishing products, okay? And then we have the opposite. We talked about reflection, and then we have the opposite. When there's high porosity of those materials, we talked about absorption, right, Felipe? And there is, I don't know if I'm going too fast here.
Too fast.
Oh, sorry. But
you mentioned it's too fast. Just a minute.
You mentioned the priests talking in churches, and actually this is one of the things that is really hard in those type of buildings, because depending on the time that it was built, the purpose of that was different. For example, churches in Europe, they were not really for the spoken language, for the for speeches, but mostly for music. And then you have these high volumes and these reflective surfaces, also determining the type of music and the way those musics were made. So this is why we have long. I'm trying to remember the name of those types of music when you have a huge choir and everything they say is very long, and then you have a
like a Baroque.
Yes, Baroque music. It's a type of that, and then they go on each other, the sounds and everything, and then you have a whole atmosphere made by this music. And this is only possible in large rooms with high reflectance. If you had one guitar, one single person trying to play one guitar in a place like that, it wouldn't work. You would need a smaller room with more porosity, more absorption, so you could understand that music. So this is amazing when you think about how music developed and the places where people built to play those types of music. It's really tightly connected. Sorry, I just went along with that so I could give Felipe some time here. But anyway, we can really get excited with all that. But please excuse me. Sorry for that. Fine. Okay. So absorption. Absorption is the opposite of reflection, of course. So when you have high porosity, the sound will enter those pores. And because of that, it will reflect inside those pores and it will lose intensity because it's like pinball. You know, I don't think Generation Z will know what I'm talking about. But pinball used to be an arcade game. And then you would press a ball and it will go really fast inside those boxes and start hitting all those obstacles. And when in time, it will lose energy. The more you hit, there were some that will give some more energy to the ball to go faster. But in general, in time, it will lose energy. It will start going slowly. And this is what happens with sound when it goes into those pores. It hits so many surfaces that it loses intensity. Okay? I don't know if I just... Okay. So the greater the porosity, the higher the absorption, especially for high frequencies, okay? Why is that? Because high frequency sound, they have small wavelength, okay? How can I make this clear? Low frequencies, you have big wavelengths, okay? And high frequencies, you have small ones. And this is why you usually speak really high. And if you listen to our video later on a higher speed, we will talk in a higher higher pitch because of that. Because you are making the frequency higher and the wavelength smaller. Okay, and
Somebody
this is why.
Okay, go ahead. Sorry.
No, please.
Now, I was just going to say, people were talking about the pinball, and it was actually, they did get the example, most of them are showing here that they did get the pinball example.
Okay, we're home. And then this high frequency, because it's small, it gets into pores easier. Okay, when you have lower frequencies with lower tones, it's harder. Think about, for example, this subwoofer sound that can even shake your windows. This is really low, okay? So what you need then is something that will absorb that in terms of, how can I say that? Amortecimento. Sorry, I said in Portuguese because I don't remember the word. Sammy, help me. It buffers.
Sound buffer? Yeah.
Yes. Yeah, because it gets pressed by the pressure and then it comes back to its original state. You might not notice, but those sound buffers, they do that, okay? So this is what you need for lower frequencies. Medium and high frequencies. Medium frequencies is, for example, our voice tone and so on. then you absorptive materials can do the job quite well. Okay.
Quickly,
This happens also. Sorry.
Quickly, talking about sound, people were saying that my microphone is creating a noise for them. I did disconnect it. Is it okay? Is it okay now? I kind of disconnected my microphone and I reconnected because we don't hear anything here.
Before we went live, I wasn't hearing that sound, but now I do.
You do? Okay, I'm going to try one more time.
Okay.
Okay.
Still the same.
I don't know. Yesterday it wasn't like this. I'm going to try to disconnect the whole thing. All right, go ahead.
Okay. So one thing is important, and this is also why it's so important for interior designers. When we deal with absorption and reflection, we are talking about the surface, the surface property of the material. And this is all about finishing products, right? So we are not talking about insulation here. We're talking about the same environment. So all the examples that I told you here until now were of one person or one noise source or one sound source in the same environment as the person that is listening to it. So when you have this condition, they are both in the same environment, then you deal with surface properties, okay? And what happens is that when sound enters those pores and it start to lose energy, this energy is not really lost. It turns into something else, and usually it turns into heat, okay? It's not really something significative. I don't know if I'm saying that right, but so that you know that this energy is being transformed into something, okay? And of course, the more pores you have, the more absorption you will get, not only for the surface, but also for insulation, okay? And then if you need to deal with lower frequencies, you will have to have inside those buffers, usually you have those wooden buffers with insulation material inside. So the thicker you have, the I forgot the word again. The width, the more width you have, the more absorption you will get, okay? Usually. Of course, they are discovering new materials every time, but usually with the regular materials we have in the market, this is what happens. And then we have acoustic ceilings, and this is something that will make this bridge to our next part of the class, when we will see that how we can apply to our design, okay? So the thing about acoustic ceilings is that this is the easier way to deal with acoustics in an environment. Why is that? Because it does not, it's not prone to dust buildup. It's on the top of everything, of course. It's something that you don't have to clean very frequent because of the same reason. People won't get in touch with it unless it is for maintenance. And it's there is not usually many details that you put into that. You can do that, but it's easier even if you need more area for absorption, you can deal with different heights. And we are going to show you some examples on that. But it's easier to deal with ceilings than with the other parts of the environment. Okay. And in this area, there is, when we deal with ceilings, there is one special coefficient, that we have to think about, which is the noise reduction coefficient. This is an average coefficient of the absorption capacity of the ceiling for the frequencies 250, 500, 1000, and 2000 hertz. So they do an average of that, and then you have this ceiling acoustic performance in terms of noise reduction. Okay, so it's a simplified way of choosing this type of material. Why those frequencies? Because these are the main ranges that we as human beings can identify. Okay, so this is why they aim at that. And then I think we can talk about how to calculate this type of things. I promise you it's not that complicated, right? How are we going here, Felipe?
Yeah, guys, I want to know if you guys are fine, if you guys are listening well. Please tell me in the chat if you are getting the content, understanding this. It's important for us to know, because you understood, right? We are talking about reflection and absorption, right? Reverberation, and we need to absorb this structure with the NRC, right? And you understood that we have these frequencies, and the NRC is going to absorb this because it's our human, right? Our human detection, right? This frequency. So it's important for us to know. Cool, great to know.
Okay, I'm gonna take this pause moment just to see if, since we took a little break in between subjects, I changed my microphone to the other one.
I don't know. I can't hear anything, actually. It's people who are listening. People telling it's perfect. Okay, I think we can proceed. No problem. All right.
All right, maybe. I changed I'm going to mark that microphone as...
Yeah. Well, guys, you will have the summary, so you can watch it, recap this later, right? So with the summary, you can recap lots of things. So we can proceed. We need to talk about the space itself, right? Some stretches more into interior design. Now you know the main ideas. We need to go further, and we are going to show you some stretches here, right? It's going to be great.
Okay. We are going to show you a calculator made by people from the LEED certification. Okay, so I don't know if everybody is aware, but LEED certification stands for Leadership in Energy and Environmental Design. It's a worldwide certification right now. It started in the US, but now it's all over the world. And we have this tool. It's a very useful and easy to use tool. Okay, so this is why we are showing you.
Yeah. It's yes, important please. To say we are LEED APs, right? We are LEED accredited professionals. So we studied the strategies of the certification, and we made the first test, that is the LEED Green Associate, and then we made the second test is to become the LEED AP who can handle the certification and do all the strategies. So I am a person who has accreditation. I did 2 projects, 3, but one wasn't completed. Sammy did 5, right? And Tiziana more than 20. So Tiziana is the winner here on LEED certification. And we are architects as well, just for people to know, right? Why these crazy people are talking about architecture, right? Because we are architects and LEED AP, just to mention, right? It's important.
Just to cover some basics, because we just yesterday we noticed that we told you our names, but we're so used to talk with our students that we forgot that we were here with completely new people, and we needed to welcome you and let you know like a little bit of our background. So why are these people talking to me about sustainability? Very
Yeah.
important.
Yeah, and this is why we do this. Because we work in the we still work in the market. We notice that people lack this kind of information. How do I do this? How do I make it happen? And this is why Hugo
Yeah.
is here,
Yeah,
right?
we could say we are dentists and we are teaching you sustainable architecture. You'll be very crazy, but no, we are architects and lead APs, just for you to know. All right, let's proceed.
Okay, I'm going to share my screen here.
You can go on.
May I?
Sure, sure. You can
Okay,
go on.
okay. Okay, let's share. I'm going to increase the zoom. Is it okay to read for most
I think
people?
you could zoom a little bit more to fit the screen.
Okay.
Yeah, I think it's better. Cool.
And again, people, if you cannot read this, increase the quality of your video. Please try to watch it in a bigger screen, not on the phone. So it will be better for you to understand everything here, okay? If you can, of course. So this is what the calculator looks like when you open at first time. So it gives you all the steps that you can go through and understand everything that you need to. First thing that I'm going to do is change the units, because we here work with the international system. But if you work in a place that you use the imperial system, you can choose that. And then there are some instructions. If you are working with a school, there is instruction for schools, for healthcare projects, and for general projects, which is the one that we are doing today. Okay, we are aiming at an open office, open plan office, because it's what most people are dealing with now that they are going back to their workplace. I hope so. At least, but this is something very, very common, right? If you need to know more about what this calculator is based on, there is a tab here for assumptions, and they give you all the standards where they come from, all those indexes, those coefficients, and so on. Okay, so it gives you for background noise, for sound transmission, for isolation, acoustic isolation. I'm going to go quickly in this tab here, so we can go on. Reverberation time, this is something that we are going to work with today. Speech privacy is related to reverberation time. And acoustic, because it deals with the absorption or reflection characteristic of the surfaces. Acoustic finishes and the design coefficient, so they give you already this relationship with the type of space that you have. Okay, so if you need some idea of what you're searching for, you can find it here. Okay, so it's already in this calculator. You don't need to look further if you don't have to. Okay, and then we are going to talk about noise reduction coefficient. Okay, about first things first, background noise. Okay, what is background noise? Is all the noise that you hear aside from the source that you want to. Okay, so it's the traffic, it's the air conditioning, it was that problem with Sammy's microphone, and so on. Okay, so this is background noise. If you are in designing in a place that already exists, you might want to measure the sound intensity in that place. Okay, so you can have an idea of the background noise. But if it's a new project and you are developing this along with the architects and the other teams, you can count only on the HVAC background noise if there is an HVAC system. And this is what I'm going to show you. Where do you find this information? Okay. So what we are going to do here, it asks for a space ID. So we are going to use that in the Office 1, for example. What is the space type? The space type is a office building, open plan office. Okay, so this, if we see it already, we already have here some levels, but this is for schools. It has already filled in for schools, but not for the other projects. Okay. So let's move on.
Just to let you know, guys, right there where Tiziana chose office buildings, open plan office, usually when you download the calculator, you will see a drop-down menu with all the options for you to go.
It's not appearing.
We don't see this on screen because we're sharing screen, so it doesn't show the same way for us. But anything that shows there with the little arrow on the side, they will have a drop-down menu and you can choose from it, okay? So she is choosing from a menu.
Yes, it starts with rooms with intrusion from outdoor noises and traffic noise to residences, hotels, office buildings, and go to performing art spaces, hospitals, and laboratories, okay? I will describe to you then because I wasn't aware of it.
I need you should share your screen itself, not the software. Maybe it will appear in drop down menu.
Stop. Let's try again. Share screen.
All right. Another thing that I want to say to you guys, the link for you to download this Excel calculator will be on your summary.
Yeah, now it's
and we will have a better way to share the summary with you this time. We're not going to go with Instagram this time.
It's so cool.
Okay. Do you see it now?
Yeah.
Okay, so what I was talking about is here. So you have a list of rules. Thank you, Felipe, for the tip. And then we are going to choose a method of sound rating, of sound background noise that we are going to look for, okay? We are going to look for dBA, which is the sound that we hear. And then, but you can choose another one if the manufacturer gives you the other ones you can choose, okay? And then it already filled here, okay? So we have a maximum allowed background noise level, which is 45, okay? And we are going to put here the background noise level of the HVAC that we are going to search for, okay? So let me just, I have it very quickly. I'm going just to open the HVAC specification so you can see that. Okay, I have to make it larger. I'm going to share the screen again, not the screen. Okay, sharing.
Sharing?
Okay, here. Do you see it? All right. This is just a... Sorry?
Fine. We are seeing this.
Okay. So this is just an example of HVAC system. Of course, you will have to talk to your mechanical engineer to see what type of unit you will need and the capacity of this and so on. But you see here, I'm going to make it larger. It says sound pressure level outlet. So this is the sound pressure that we are aiming at. It's in dBA, as I told you before. And there are 3 types here that goes from 3 types of units, from 35 to 38 and 41. Okay. Let's choose 41 because we need a stronger unit, and we are going to put it here. Do you see my Excel file?
Yeah.
Okay, so 41, and it already says to me that it's that the background noise is okay for that place. If it were 48, it says no, because it's too much background noise. It will make people uncomfortable. Okay, so this is something that it's important that you talk to the mechanical engineer, because sometimes people are really concerned about thermal comfort and energy efficiency, and they don't think about the discomfort that that unit will cause to people. And when it's too loud, they will turn it off for some time because they need some peace at that moment, and then it will unbalance everything that was simulated and calculated before. Okay, so this is one thing that you should have in mind. Acoustics, it's about comfort, it's about quality of life, but it also can unbalance all the calculations that you did for thermal comfort and energy use. Okay. Next thing that we are going to talk about is, of course, the noise reduction coefficient. We talked about the ceiling property. Okay. And this is where you put the ceiling characteristic. Okay, so you put here office 1. Is it okay to read?
It's okay, yeah.
Okay. And then you put, okay, ceiling X. This is a mineral ceiling, and then you have this the name of the product and the type of product, which comes from manufacturer X. And then you need your noise reduction coefficient, which is that average coefficient from all those frequencies that I talked about. Okay. First things first, we already know the area of the ceiling that we are going to apply. Let's say it's 49 square meters. It can be less if you're doing a composition in the ceiling. It's all right. You just put more air, for example, 20 here, and then ceiling Y here, and then with 29. Okay, and then we have 49 square meters, and you can make this composition. Okay. And then we need the okay, this calculator sometimes can be a little tricky. Let's make it simpler. Okay, I'm going to show you now how to search for those coefficients. Okay, let me just open here a sample, an example of what you can look for. Sharing again. Do you see it here, the website?
Yeah.
Yes.
Okay, so the first thing that you have in this description of products is the sound absorption, the NRC, noise reduction coefficient. So this is not that hard to find. If you cannot find, you can ask the manufacturer for it. Okay, this is worldwide known. And then it's easier for you to find. Felipe, do you want to add something or maybe help them?
Yeah, I'm making a drawing here. Just finishing.
Okay. Do you need me to stop sharing?
No, just a minute. I will just. I'm just finishing writing this. Just a minute.
Okay.
Noise reduction coefficient. Just a minute. I'm sorry.
Okay, so you see that it goes from 0.75, we have 0.5 here, 0.60. So this is something that will help you choose not only for aesthetics, for hygiene, for all the things that you already have in mind for your design. This is something that also helps you choose the right ceiling for your space, okay? Acoustics.
Yeah. Just to mention, I will just show my screen here for people. What we are talking about is this, right? NRC, right? So we are going to see some products as TC is showing you. And you need to understand the difference between these two, right? The noise reduction coefficient, we are going to talk about the absorption of the panels, right? So let's say we have a panel here. We are going to absorb this type of noise. And when we are talking about NRC, is about the capacity of the material or not to, let's say, to trespass, right? Let's say we have this panel here on the ceiling, and we don't have, let's say, a wall in this area here. We don't have this to avoid this noise coming from this space. So the CAC is going to be the property of the material or not to trespass this area. So I just wanted to show the difference between these two before we proceed and see some materials of this manufacturer. This manufacturer is not paying us anything. They should, but they are not.
Actually, that's a great. Everything that we show here is because we find it easy or to illustrate. We don't have sponsors, so anybody that wants to be the sponsor, then like feel free.
Yeah. So
not even the USGBC, right? They can sponsor us too. We're here. We're teaching about them.
Yeah. So we have this manufacturer called Armstrong, right? So we are going to see some standard, right, NRC ceiling tiles that TC has filtered here. As you can see, right, we are at home, commercial ceilings and walls, standard NRC ceiling tiles. We are just going to look on ceiling tiles. And as you can see here, right, sound absorption up to 0.75. So the higher, the best. And sound blocking up to 40, right? 40 decibels. So you can understand about this. Light reflectances. Pay attention in this. We are talking about acoustics, but here you can see the light reflectances. And this is going to be very important for our last class on lighting design, right? We are going to make simulations on lighting design, and you are going to see that reflectances can make a big effect on reducing lighting density and save energy. So this is a very cool thing that they put here, because you need to see things together, right? Because when we are developing an interior design, you need to understand that sometimes acoustic strategy can make a difference on your lighting design, and you can have synergies and drawbacks depending on the strategies that you are using, right? So as you can see here, right, we have lots of other.
The recycled content is there too, which is very important too for our sustainable materials.
Up to 87%.
Yeah. Is a very good rate for recycled content.
Yeah, and this is going to be in the 4th class. So we are just preparing you in all classes at the same time here, 4th class, 5th class, and you're going to understand lots of things here. Disinfectability, right? We are going to see about in the 3rd class about wellness. So lots of good things to cover. As you can see, this material here is only 50, right? So depending on the space you are, it's going to be worse for your project. Recycled content is less. As you can see, it's kind of an old technology. I could say it's an older type of ceiling panel. It's an older technology. We don't have this amount of recycled content such as this. So when you are specifying a project for a client, it's very cool to show these people these differences. So you are telling them, okay, I'm choosing this panel because you have a bigger NRC and it's important. I made a calculation of your project and it's going to be for your acoustic performance. And we know that we have a good amount of recycled content, it's more sustainable. So all of these things you should be telling, right? And if you have adjacent rooms, you will need to take care with the CAC as well, right? So this is very important, and you need to see your construction, as I was telling here, right? If you don't have a wall right here, you should take care if you have a 2 rooms like this in your project. So a very straightforward way to see things. And you can see others, right? We can compare things on this website. I could select this and this, and then we can see this compare selected items, right? We could compare here these properties, right? You can see the absorption. Oh, this is better. This is worse for the CAC. We are seeing the materials, the recycled content. This is not informing the recycled content, so I'm assuming there isn't recycled content in this, maybe. And this is it. So it's a very cool website to take a look at, right? And we have tons of materials to take a look. And of course, you should pay attention when you see the pictures of this. You can see up to 0.7, right? And you see the floor. The floor is not absorptive, such as, let's say, an environment like this. Let me find just one with carpets. Yes, this here, right? Here, I think we have, no, it's not a carpet, but we have some pictures. I think this is a carpet, right? We have 0.6. So we don't need maybe 0.75, 0.8 or something. We just need 0.6 because the carpet's going to make a big impact on this absorption as well. So you need to think about this. You need to have LEED certification is going to talk about something like this: 0.7 when you have a small volume, right, below 565 square cubic meters, right? So if you have lower than this, just like a classroom, just like a meeting room, if you have just the ceiling with 0.5, you are going to receive a credit on LEED certification. But maybe you just have a carpet, so you don't need 0.5, 0.7. Sorry, I think I spelled it wrong. I will just recap. You need at least 0.7, right? Just on the ceiling, in a small space like a meeting room or a classroom, and you are going to be fine. But let's say you have a carpet, so you just need maybe 0.5 in the ceiling. So you need to calculate these things, right? So I just wanted to recap this because this is very important. And reverberation, it's a big issue in lots of projects, including offices, right? All right, so I just wanted to make sure that you are understanding this, and we are going to recap a little more with some apps during this class as well. All right.
Okay. So while I share my screen here, Felipe, can you choose one NRC for our calculator?
Do you want me to choose from this manufacturer?
Yeah.
Okay, I will choose, let's say here, I will choose the first one here because it's 0.75, so we have a more chance to win the challenge, right? I don't want to be shameful of our students here. Right.
Okay. Do you see the calculator?
I'm seeing, yeah, fine.
Okay, so I wrote here the one that Felipe chose. We already had the area, the ceiling area, and then we have here that there's something missing because it's not complying. If I put here the ceiling area, it says that is compliant now. Okay, so I have the whole ceiling area with a good noise reduction coefficient. And then the calculator is telling me that I will have theoretically a good acoustic performance in that room. Okay. Why do I say theoretically? Because people are people. When we do energy simulation, thermal simulations, comfort, whatever, we are dealing with assumptions, right? So if someone puts a car outside with subwoofer, then it's a little bit more complicated and hard to predict. Okay. All right. And then, as Felipe told you, maybe you have a larger room and maybe you have to deal with reverberation time. So how do we do that? There is a tab here for reverberation time. Okay. And then we already chose the ceiling, and we talked about that the coefficients is the NRC is an average of the frequencies. So we are going to put it here, okay? The ceiling. And it says it's 7.75. It will be better to have this difference of frequency from the manufacturer, but if we don't, we are just going to put it here as an assumption as well. This space ID is the office. I'm going to zoom more in a bit. Okay, it's just that I have to have the whole picture here. Okay. Let me see if I can zoom in a little bit more. Okay. So you have here the sound absorption of the material, okay, with different, with 3 different frequencies, and then the space ID, so office 1, and the application. You see the drop-down menu now?
Yeah.
Okay. So open plan without sound masking, because we want to provide this quality without any additional equipment. The surface area. Now we are dealing with the ceiling that we were talking about. It's 49, and the material location is the ceiling, okay? So we have here something missing, which is the room volume here. Room volume. I told you that reverberation time deals with surface properties and room volume. And in this room, I have already. Can you tell me the volume of the room? It's 9.8 meters for 5 and for the height.
Oh, you want me to tell? Let's see. This space is 9.8 to 5, ceiling height 4 meters, area
Yes.
49 square meters. Is this?
And the volume?
The volume is not appearing here.
49 for multiply
by
49 4. Okay.
So it would be
Much easier.
196.
Okay. So we have here that the reverberation time,
right?
Yes, thank you. The reverberation time that we are aiming at is 0.8 to 500 hertz, and to the other frequencies as well. And we are not achieving that, okay? It's actually pretty much higher. No, it's the absorbing. It's 0.86. So we need a little bit more absorption to make sure that the reverberation time is all right for offices. So let's use a wall here, okay? And let's say we are going to use something that is, I don't know, maybe I can show you. I put a table. Felipe, can you show them? There's a table attached to the class planning.
You want me to
Or
show
maybe you can.
the absorption?
Yes, choose a material and tell me the absorption coefficient.
Okay, we have, let's say, concrete block, dense, painted. We have 0.06.
0.6 for 500, okay.
Yeah, for 500, exactly.
For 1000 hertz.
0.7.
And for 2000?
0.9. Sorry,
Okay.
0.09, right?
Yeah, because it's very reflective. So the
Yeah.
higher this absorption coefficient, the higher the absorption, okay? And then the surface area is going to be 20 because it's 5 multiplied by 4, which is the ceiling height. And then we have here that it is a wall, okay? And then it lowered just a little bit. Now we have 0.83. We had 0.86 before. Okay, so we need more absorption. The concrete blocks are not absorptive enough. If we change here to another material, let's say something more porous.
Oh, do you want something more porous? Let's see. We have carpet, heavy on concrete.
Okay, let's add carpet. Then we're not going to deal with the wall. We're going to deal with the...
Do a composition with the whole room.
Okay, 500.
So, for the people that were asking on the chat, like how do we calculate for the entire space? So how do we calculate these compositions? You see that Chisi is making a composition right there. She started with the ceiling because we want to use the ceiling as the higher surface because of what she mentioned before. It's a place where you will have lower chances of having problems with dust accumulation because it's like gravity works for us in this case. So, but there is still a maintenance to deal with those panels. But just saying that it's a less chance for you to have dust buildups and create problems with allergies because these are materials that are porous.
And a very straightforward way of starting to think about this here is to do your design as you regularly do, and then you get all the surfaces and you put in this calculator. And then you see if it's going to be comfortable or not. And if it's not going to be comfortable, then you will need to change some material to a more porous one, for example, so you can have a lower reverberation time, okay? So you don't have to go too far away from what you already do. You just have to check if all those materials are going, indeed, to give people acoustic comfort. Okay.
All right.
Yes.
I will share the carpet here. Can I show?
Okay.
So
please.
0.14.
14. Okay.
Yeah. So 0.37.
37.
And 0.60.
60. Okay. And we are going to use it on the entire floor. So it's 49 square meters. And we have here the floor. And now you see that we have a lower reverberation time, especially, as I said before, especially for the high frequency of 2000 hertz, because it's very porous. So it deals better with those higher frequencies, middle and higher frequencies. So now we are achieving a good environment. So it's just that you get the area of that material, and you put here as a composition with all the specifications from the manufacturer. If you don't have this specification, there are standards that already give you those coefficients, those absorption coefficients, so you can have an estimation of the performance of your design. Okay.
Just to mention something. What is comfortable in this space? So let's say this space is going to be, I don't recall, 0.7, 0.
What we are aiming at, 0.8.
Okay, 0.8.
For all the frequencies.
Yeah, so depending on the space you have, you are going to have a value to achieve. So usually when you have a classroom, when you have a meeting room, you are going to need 0.7, 0.6, 0.8. And when we are talking about something big like a gymnasium, it's going to be 1.5, 2, or something like it. So bigger the space, and if you don't need to hear very good a thing, you will have higher values. But if you need to have something You know, you are in a classroom, you need to learn, so you need to hear, you know, very precisely, right? So this is going to be a lower value.
Yeah, you need to have clear, understand things clearly. The one thing that I want to share with you guys.
Can I stop sharing now?
Yeah.
Okay.
One thing that I want to share with you guys is that as interior designers, you have more of this complexity when you're thinking about acoustics. It's very complex to calculate. Some people mention that I try to do it by hand. It's very time consuming. Yes. So with this table that we showed you here on the Excel file, it is easier for you to compose these elements or to evaluate the room that you have designed for. But if you have a bigger space, usually you work with an acoustic engineer. You are working with a person that it's actually dealing with this. It is a complex subject. It's it's just like being with your mechanical engineer for air conditioning. For smaller spaces, understanding the basics and having these tools to help you, you will be able to calculate this yourself, and you will be able to understand if your space is achieving this. But if you're dealing with complex elements, don't try to do this on your own without consulting with someone that it's qualified for this. You don't want to jeopardize. Bigger spaces, they have so many inputs that you should be calculating. So think about that. Think about that you have a team of engineers in your project, and you should use them for. But knowing these basics will give you the right directions. You will not be just listening to them, but you will be trying to contribute with them and trying to go in the right direction, asking the right questions. The idea is when we talk about so many subjects here is that you are not supposed to be the expert of all, but you are supposed to know enough to ask the right questions or to know that somebody is doing their job right or wrong. So when you have this basic knowledge, then you can question or you can contribute further with the design of your space. You are regaining control of your space by having this on your side. So this is a great thing to just keep in mind, all right? We know it's very complex, so bear with us. That's why acoustics is the underdog. Sometimes people just like give up. I'm not gonna check this.
Yeah, but it can make a huge difference.
Yes, absolutely. And with health and concentration and to get the most out of the environment where you're working or studying, especially, yes.
Because we have something, right? This thing that we get used to good things and bad things. And when you are inside a space like this, in a bad space for a lot of years, you start getting used to it, but it starts to affect your health, in the long term, right? Or medium or long term or something like it. So it's very important to handle these things inside a project.
Can I show very quickly the difference that it makes?
Sure.
I'm going to open my audio here. So
I'm saving some images here for the next part, so you can proceed.
Okay. So please don't mind the sound, okay? But it's important that we hear, of course. It's acoustics. Okay, let's go. I'm going to share my screen because I forgot. Okay. Let's...
Education. When I see a classroom that looks like this, can you imagine how this sounds? I'm forced to ask myself a question. Now, that's a little unfair. Some of my best friends are architects. And they definitely do have ears, but I think sometimes they don't use them when they're designing buildings. Here's a case in point. This is a £32 million flagship academy school, which was built quite recently in the UK and designed by one of Britain's top.
Do you hear it?
Yeah.
Okay.
Architects. Unfortunately, it was designed like a corporate headquarters with a vast central atrium and classrooms leading off it with no back walls at all. The children couldn't hear their teachers. They had to go back in and spend £600,000 putting the walls in. Let's stop this madness of open plan classrooms right now, please. It's not just these modern buildings which suffer. Old-fashioned classrooms suffer too. A study in Florida just a few years ago found that if you're sitting where this photograph was taken in a classroom, row 4, speech intelligibility is just 50%. Children are losing one word in 2. Now that does.
There's a.
What's going?
Let me. What I'm trying to show you here is that there is a decrease of quality in the sound, that it can be really serious to those spaces. Okay, so if you can later watch this TED Talks, TED Talk is really important. It's really interesting, and he deals with exactly of what we are dealing right now. Okay. All right, let me just change it here. I'm going to show you more sounds in a bit. Suddenly everyone went quiet. Let me just close the sound here.
I just muted my sound.
Okay, much better.
Cool. All right.
All right, let's move on. Felipe just showed you a picture. He was, when we were talking, he was showing you a picture of a space with a green wall, right?
Can you show you again?
Yes, please.
I'm just getting lots of images here, so you can just look at it while I'm doing others here.
So
yes, this is a part that it's very interesting. So many people did ask about green walls. With the combination of biophilic design, now we're thinking about acoustics. So this is you see how we start adding things to and complexity to the design to understand that every item that you put, it probably touches more than one subject that you should be analyzing.
Okay, and this is something really interesting, and it's so important for the interior designers because it works for you more than it works for the architects. Please have in mind, green walls, they don't really work for isolation, but they do for absorption, okay? Let me show you really quickly here. I study. Do you see it here?
Yeah, we are seeing.
Okay, so it's called Evaluation of Green Walls as a Passive Acoustic Insulation System for Buildings. And what they did, I'm going to fast forward here just to show you how they planned the experiment. But we have a place here, a small area in the wall that they put this green wall, and they try to evaluate the isolation performance and the absorption performance from the isolation from between different rooms and the absorption characteristic of that green wall in the same room for the acoustic quality of that same room. So they did have this this wall between the rooms. So we have the source room with the green wall, and then we have the receiving room for the isolation test. And what I want you to see here is on the results. So here we have the sound reduction coefficient, and the green wall wasn't really good, but I wanted to show you another one here, which is the sound absorption coefficient here. Do you see the green wall is this light green here? Let me increase the
Zoom.
Okay. You see that in the lower range, the lower frequency, it works better than any other material. And when it goes to the middle frequencies here, it loses only to the fiberglass board and in the high frequencies as well. So it's a really good absorption material. If you have a green wall in your office, in the indoor environment, it works really good. It gives people biophilic design. It gives people biophilic feeling of being in touch and close to nature. But it also helps with the acoustic properties of that area. So for interior design, green walls are really good. Okay, so we wanted to give you this good news, right?
Yes, yes. Because there is a confusion, and there's a few blogs that I have seen that they have shared the acoustic properties of having green walls, but not exactly explaining how they can help you with acoustics. And sometimes people think it's sound isolation, or different things that you need a whole lot more to work with, and you need to understand that analyzing these materials and the way they perform with valuable data. People research your sources when it comes to this kind of things, and when you find the source, see the type of tests that they were performed. Like TC has shown today, and we talked about the plants and air quality and the NASA study. It's not just repeating the headline, but understanding the concept of the study and how they were performed, and does my environment work or perform like that, right? So it's a good thing.
I'm going to ask Felipe to put that reference in the summary so you can read the method that they use and how they did that, okay?
Yeah. Just to make sure, guys, we are giving you here a bonus, this table of some sound absorptions, so you can recap this and see it for yourself later, right? And the acoustic calculator link is here, okay? I'm just putting here the link for you so you can get this after the class. So now we have some pictures to illustrate some situations as well.
Yes, if you go on the picture right below the green wall, we have some baffle panels. So
baffle panels is this one.
These are some pictures of the different combinations that you like. A lot of people ask, like, how can we do these combinations to work with acoustics, right? And there you have some baffle panels that are coming from the ceiling. The advantage of using the baffle panels is that, as you can see, there are many layers of them, and you can increase the area where you're going to use this surfaces. So if you were to use a flat surface, you probably would have half of what you have if you use the baffle panel. So that's one way of multiplying your the properties of this area. All right, so that's one of them. The one that it's right on the side, I guess, yes, acoustic clouds. Yes, we can go to acoustic clouds. Acoustic clouds, they are very good when you have open spaces, big open spaces, like you can see this office, and you're not using the acoustic ceilings. You want a different look to it. You can use the acoustic clouds. One thing that we have to think about when we have open spaces is just like the TED Talk says, open spaces with offices and classrooms, it could be a nightmare when so many people are sharing information or talking on the phone or even talking to their colleague. So you have to create a proper acoustic environment and micro environments. In this case, when you're using the clouds, you are creating that micro environment where they are applied to. So the acoustic clouds, when you look at it, there are so many ways to use colorful materials, different shapes, different quality of materials too. So it can be something, this one happens to be a very flat one that we are showing, but there are so many ones that are that could promote a very nice design to the space, to enhance the appearance of the space and fulfill its purposes. So like if you have a big open reception area in a hospital, you can create right on top of the desk where you are sharing information or where you are doing the check-in, you can use an acoustic cloud. So you will control that environment where information is being shared and people need to listen and have a better acoustic quality. So those are things that can be used. Acoustic clouds are also can be used in different auditoriums, depending on the type of auditoriums that you have in a school or even in an office setting. The next one is...
I'm just kind of crazy here. I'm sorry. I will just keep the link for people so they can see this.
Yeah, we're going like this with
right, the green wall study. I'm just kind of random.
Oh, yes,
doing
to put the
random
reference
things.
for the study, absolutely.
Just to do another random things is, guys, how are you doing? Are you learning this class? What are you thinking? Tell us what you are thinking about the class. I'm thinking it's terrible. I'm punishing myself for 2 hours. Listen about acoustics with these people because I want to punish myself. You can tell us the truth because we want to know the truth. What you guys are learning on this class, please tell us. Okay, it's super interesting, learning a lot. Apparently, we don't have people punishing themselves. It's very cool to know. Don't punish yourself.
I know. If we pass,
let's go on.
We pass the
I
test.
really get
okay,
worried
good.
when you say that. Okay.
All right, so after acoustic clouds, Philip, and I'm going to take the moment that Philip is showing the carpet out there. We have carpets or rugs, right? So one thing that we have to think about when you're using carpet or when you're using rugs is the quality. The quality of the materials and how they are going to be maintained, because they can be a source of absorption of dust, and they also can be applied with materials that are toxic for the environment. So when you are using rugs and carpets, please be mindful of the air quality of the space that can't be compromised. So we have lots of carpets that use recycled materials that do take away the carpet when its life cycle ends, and they can recycle too. This is very important. Where does it go after this? And using in the areas where it's proper, and when you're not going to cause allergies, or if somebody has allergies problems, then you have carpets and rugs are very good for acoustics, but you have to take into consideration those things when you're thinking of the space, right? How many people have been to those movie theaters where the carpet smells so bad and stale, and and you are not paying attention, you're just smelling that thing. So I must say, when
grandma's house, it's like this.
Where are you watching
like really old, like dirty looking things. So
not my grandma.
I'm very concerned about materials when it comes to other things, just and not just the main application that we're talking about here, in this case, acoustics. So So here in
Alright.
you have carpet tiles that are showing. Carpet tiles too are more sustainable than regular rolled up carpets usually, because they are scrap tiles, and they can use the product even further. The next one that we have the opportunity to do is the booths. If we use the privacy booths, where you are creating this paneling around, then you are creating with acoustic materials that you can use the properties of the cloth, of the materials that are the exterior cover, to create a very interesting space, create that privacy that you need, or for that moment of a private call in an office environment where you need a little bit more of quiet space. You can create this micro environments with the acoustic panels and use them as decoration. I thought this idea was so cute too. So cute is good, right? That's a technical evaluation here. It's so cute.
So cute. Yeah.
Very technical.
This is so
Anyways,
cute
we
as
can
well, I
have-
think.
What?
This is cute as well, I think. This one with
Yes. Very cute.
We're going to invent the cuteness coefficient.
The
the
cuteness
cuteness
coefficient
coefficient, yeah.
you have to take into consideration when you're doing design, interior
Yeah,
design.
we are going to
And
use
you know why
unicorns.
you do because
Unicorns in all areas.
we have very coefficients that we have to take in mind when we're doing designing our spaces. The cute coefficient and also the pocket coefficient,
Yeah.
which your client will be dealing with. The client will want to know how much does it cost, how much am I saving. So it's very important for you to present that.
We could use unicorns in all spaces to improve fitness, right?
Yes.
So this is a 4 of 5 unicorns.
Yeah.
Yes, that's the evaluation there.
My daughter would love this.
Well, let's go back to the class. Go back to that area where you were showing the grid right there. Those are private zones where you can create an enclosed booth. And this is, you can have either like phone booths where you have just that one person space, or you have like smaller meeting rooms, right, for 2 or 3 people to have a quiet talk there. So in big corporation spaces, those different areas where you can offer variable environments, it's very helpful for you to work there. Understanding the acoustic insulation properties of these booths, it's where we're going here with. And when it comes to acoustic, you have sometimes places where you have limited intervention, or you are inserting a store in a mall, or a place like this where you have more people in different environments to deal with. Here you can create combinations of space. You can take a look on the ceiling. You have there wood, and behind the wood, you can add a layer of acoustic panels aside from just the properties of the wood. Then you have some places there where you have a hanging green space there, or places where you have open space. So balancing this, it's something that can create depth and interest in your space. With the limited intervention, then you have to use, I think there is a hanging wall there, a hanging green wall. If you can show that picture for me, please, Felipe.
All right. Here, right? This one?
Yes. You see there how they use these hanging walls with the hanging panels. And right there in that corridor, you have a limited intervention where you have some of your panels working for you, some of the greenery working for you. And are you going to get optimal in a space like this? No, you have limited intervention. You have to deal with that micro space that you are developing. And we also have the classical perforated panels with absorbent materials inside. This you're going to see usually in restaurants, or you can see some auditoriums too, some great bigger meeting rooms too. So behind that that panel, that wooden panel, you will have also some materials that are absorbent right there. So this is kind of like when you see a panel like this, and there is absorbent material right behind it, you have to understand there's maintenance, there's air quality, and this awareness of what you're doing with the space is to maintain. Like TC has mentioned many times before and yesterday, if people cannot get used to it, or if this space is not working for them, they will change it. So if you put those wooden panels, if you put that absorbent material behind it, and it is too difficult for this person or their lifestyle to maintain this well, and it starts to look dirty and starts to degrade this space, they will replace it, and they will not ask you to come and replace that. They will probably do something that will decrease then the acoustic properties or the isolation property, or whatever it is that you have intended for the area. So it's very good to have an interview with your client when you're talking about the purpose of the spaces. How do they do their maintenance? How is their daily basis? So you can incorporate that on your decisions too. So we have many sustainable materials that you can use in acoustics. And one good place for you to check is the Cradle to Cradle products library. You will have materials that are certified, or you have there some companies, but we're talking here worldwide, and not many places will have materials that have been certified by Cradle to Cradle or that are attested. So let's go with starting with some types of materials that could be your let's say more sustainable choice for acoustics. We have limited choices here, but we can look into wooden panels, and of course always check the properties of your materials. I will go into length on how we select sustainable materials on day 4th, but we can look at fibers, natural fibers. There are plenty of panels that have been done now, and more are coming, with wood fibers, with coconut fibers, some materials that have been made from hemp, some materials that have been made from paper that is recycled, plastic that is recycled. And also when we talk about plastic, remember what we saw just there, the amount of recycled content. Because just saying recycled content, it could be 10% recycled, could be 5% recycled content, and they're still not telling you a lie. They are telling you the truth. There is recycled content, but we have to look at how much. And this is our job, to ask our suppliers for more information and transparency on where are this coming from. Sheep wool, straw bales, those materials that can be used in compositions. Some people mention cork. Yes, cork is also a very good, but cork is not available everywhere. Look at what is available locally in your region as an abundant natural material. So if you have wood fibers, or if you have plastic that is recycled. I don't like to say too much plastic, but yes, if it is taken away from the environment, if it's recycled, not recyclable, then yes, I'm for it, because we're taking away from the environment. And sheep wool, those are materials that are more like worldwide available. And cork is something that it's more regional, even though it is exported everywhere in the world. We need to see our carbon footprint. How much this material has traveled to get here to fulfill this purpose? Can I? So can I use these materials? So those are another thing. Another type of materials is also scraps from cloth. Different types of cloths that have been compounded into a board. The important part is for you to understand your supplier, their chain of command, and their supply chain, right? In how these products got there. So you can use materials that are alternative materials, understanding their property, understanding the safety and toxicity of these materials, and if they are fulfilling your purpose, if you can measure. So yes, bamboo too. Bamboo, it's also something that it's local in some regions of the world, and it's very, very abundant in some places. It's very sustainable too, because it's a rapid renewable material. But if I'm bringing to a place where it's not, or if it's extracted
Not
by
here
yet.
Not here yet.
Not here yet. Here in Brazil, we have some kinds of bamboo, and most bamboos that are grown here in Brazil are actually suitable for furniture. Not many areas in Brazil grow bamboo that are structural, as an example. So understanding where your materials is coming from, it's very important.
Let's go on, guys.
Yes,
Yeah, but please don't miss the class 4 on materials. You know that it's going to be a lot of content.
Yeah,
I will talk forever.
We are going to show a software here that you can use. It's called Acoustic Pearls Room Acoustics Calculator. You can see here, right? So you can download this software, and I will be doing this in my cell phone. I will be showing you this. I will click on this acoustic calculator here, and we are going to use this. Maybe you can use this in your project as well, right? So you can see here on the right corner, sample building, office building. I will click on this, and you can see we have, of course, we can create this from scratch, but I will just go to the open plane office, right? So you can click on this, and you will see the composition of this space, right? As you can see, we have a rectangular space. It's using a standard called EAN 1841, right? And it's an open plan office. What we are calculating here, it's a rectangular. We could change this for L-shaped, any shape, right? We can do other different things here, but I will just keep it as it is. Length of 12 meters, width of 80 meters, height of 3 meters. So we have the volume, it calculated automatically, 288 cubic meters. And then we have the construction, right? The construction composition of the ceiling, of the floor, right? So you can see here, right? Timber construction, it's already here. Floating composite floor, right? We are using this on floors. And this is the lower part of the floor, right? Parquet laminate. Walls, massive construction, lightweight is going to be important as well. Windows, you can put the square meters that you have here, maybe, but let's keep as it is, to 20 square meters. I will keep as 20. And we have 12 workplaces, right? We have furniture, 12 workplaces. As you can see here, we have the required equivalent absorption area as 66.2 square meters. So it's a tip that it's giving you, right? And you have this absorptions, right? So you can see here, we have these elements that we can use. So we are using these color fields, 1 meter and 20 centimeters. So you can put everything here. But what's important is this results, right? As you can see here, we have this results here, but I won't see these results. We are going to see the reverberation because it's more important now for us. So we can see the reverberation time, right? We can see that we have two areas here, I will use this reverberation times. And without furniture, without absorption, and without people, we see these red areas, right? And you see the reverberation time is really high. So between 1.6 to 2.2, and you can see the frequencies on the on below this chart, right? 125. So we were talking about 500, 1000 and 2000 because it's more like the human year, right? So we can see that this red area without absorptions, we would achieve a better, a very high reverberation time. It's going to be very, very a very bad place to be working with. But when we are using this absorption spaces, we go to the blue, right? So we can see here 0.8. And when we see 500, right, between 500 and 2000, we can see that we are achieving something like 0.6 to 0.45 reverberation time in seconds. So we can increase a lot this space. But let's say we were not using something like it, we would use something different. So we could change things here. So we could maybe remove this. Let me just change a few things here. Let me make a big volume, because it will be very bad for this space, right? To have an office space like this, just a very crazy space like this, and see the results here below. Oh, it's not calculating, right? It must be 900. I exaggerated here. Let me try to put something more relatable, maybe 3410 or something like it. I think it's
Felipe is using this on an iPhone, but it's also available for Android phones. Okay.
Yeah, it's not calculating. I think I should be doing something. Yeah, I just broke the app. Let me try again. I just broke the app. What I'm going to do now?
Well, one thing important to have in mind is that this is an app from a manufacturer. So the products that they suggest are the from their product list. What we are suggesting to you, if you are going to use this app wherever you are, is that you have the specifications of those materials. And then you can use that as a basis to choose your materials in your area, regardless of the manufacturer. Okay, so you can have the absorption coefficient that you know that works because you ran through the app, and then you can search for a similar product where you live or work.
Yeah, I'm changing the types of here of freestanding elements or seating elements, and when I put more, of course, I will make it better, the reverberation time. But if I remove this, I will just I'm putting more here, so I'm making it better, right? So let's put here 20 or something, so I make it better. But when I remove, I can see, right, I make it worse. The blue right, the blue line here is getting up. We don't want this to happen, but let's do this. Let's remove this 0 0. So we remove this. The blue line equals the red line, but let's put again 30 here, and let's put here something 30 here as well. So I dropped down this blue line. So this is a very straightforward software that you can use in your projects. Okay. So I just wanted to show you this, and you can use this in your projects as well. All right.
Yes, you will have time to play now with the Excel calculator and a app.
Yeah.
We just gave you 2 tools today to make acoustics easier and not to make the acoustics the underdog anymore. So let's use that.
And guys, just to conclude our class, we wanted to have something in mind. First, what Sammy told in the beginning of the class, and we also mentioned the whole time here. If people are not comfortable, they will change the environment. That means more energy, not only in operational energy that is being used, but also the materials. They will change the materials, and that includes wasting resources. So we don't want that. Okay, this is why we have to be careful about acoustics. Also, it's about quality of life. So you don't want to be more tired at the end of the day that you would because of bad acoustics, right? Also, and also because of what Sammy said at the beginning, this can also have heart disease implications. But we talked the whole class about absorption, about lowering the reverberation time. But sometimes you do want some reverberation time, longer reverberation time. And this is when you want liveliness in your room. So depending on the atmosphere that you are creating, you want more reflection and less absorption. So this is when you have, for example, places where the amount of people create a movement, or when you want people to feel that they are part of something bigger. Okay, so this is why you have big reflective lobbies or common areas in universities. They are symbols of innovation and resistance. And when the students are gathered together, they create this atmosphere. Okay, something's going on. Okay, so this is important. You want reflection in those spaces. Also, a very cool example is the New York Central Station. And I want you to listen the difference of areas in the station just to know that what happens here. I'm going to just put the sound. I'm not going to share the screen. I don't think it's necessary. I'm going to put my microphone here. In the beginning, what you will listen to is a very small area where are all those ATM machinery and with low ceiling, okay? So this is the sound of a low ceiling confined area in New York Central Station. Now you will hear the main area. Again, the one in the beginning. Oh, sorry. Let me go to the one in the beginning again. Oh, now this is the open area. And this is the one in the beginning, the enclosed one. Did you listen? Did you hear the difference? I hope so.
Yes.
We are hearing the difference.
Yeah.
So the difference is exactly this reverberation time. The Central Station in New York gives you this feeling that something is going to happen and that your life will change there, because this bustling noise gives you this this feeling that, okay, this is the place. Okay, so if it were confined and without reverberation, it would just be a regular day. Okay, so remember, it's about atmosphere, and sometimes you do want some reverberation.
Yeah.
Yes?
All right.
Yes,
I think this is it for today, guys. This is it.
Yes, I guess we concluded acoustics. Guys, thank you so much for being here. So many people are still here. We know that from day one to the next day after we conclude a first class, we know the curious people are gone and some people that are more focused are still here. And we know that we are not going to just stay with some of the topics in a very superficial way. We're going to try to give you something that you can work on with, something that you can use right away. And like Felipe mentioned on the first day, if you can come out of this classes here, like 5% better with your design or your intentions of design, and you're going to keep on growing and keep on researching, we have fulfilled our purpose, which is to plant this very important seed, which is to better our construction environment. We need to better plants, better indoor environments, and also to help with the outdoors, with our impact in the environment. We are one of the highest places polluting in interior designs. It's a place where you do a lot of renovations. You have the chance to change materials a lot. And if you don't choose your materials or you don't choose the proper way of applying these techniques and the architecture techniques to your space, you will create this heavier carbon footprint of exchanging, of renovating without actually the place fulfilling its purpose, its life cycle with when it was planned. So let's plan for flexibility, for durability, and for purpose. Let's think of this so those places will last and these places will fulfill their life cycle, and they're not just going to be renovated constantly and creating more stress on our resources.
Yeah. Guys, just to make you sure about the summary link, so let's tell again. So first thing, like this class, there are 4,000 people watching live and we have 1,000 classes. I think people are not enjoying, guys. I don't know. Maybe they are just randomly here because they don't like our classes, right? So please like this class.
They have to close the chat window to see the like button. I didn't know that. We have to. We are from the different angle. We're not the spectators.
Yeah. So like this class. Second thing, subscribe to our channel because there will be crazy things going on. People who subscribe will know first. And to get a summary for the class 1 and 2, right? I saw in the beginning of the class, people got problems on Instagram. We got problems with Instagram. So we are going to send the two summaries, first summaries on this links. And I put two, okay? First, insugreen.io/yes. Simple like this. And why you can't reach the website now, maybe because lots of people are reaching on this at the same time. So it's normal, but the website is resilient. It's going to be up in some minutes. So wait some minutes and you can go there. Or you can go to our Telegram channel, t.mi/ugreen, okay? So you can go there in our Telegram channel and get there. I will be sending these two summaries on the Telegram channel as an alternative. Telegram won't crash, okay? I promise you this. But our website, usually we have a very, we improved this, the servers. We resized the servers 3 times, but you keep crashing websites because lots of people from all around the globe. So it's normal, but wait some minutes and you can get to the website, or maybe you can get on Telegram and you are going to get the summary. So don't worry about it. Certificate, we are going to tell you how you can get a certificate in the 4th day of the event. Okay, so you need to be in all days to get a certificate. There is not certificates for people who doesn't watch classes. It's crazy, right? So you need to watch all classes to ask for certificates. There are people here asking for certificates. Why? I don't know. It's crazy, right? Because you need to watch all classes to get a certificate. You can get a certificate up front, right? It's kind of Very simple, but there's just a few people telling this, right? So this is it, guys. So please like the class, support our work, and subscribe to our channel. Will be lots of great things going on. And to get summaries, I'm telling you again because we get lots of people talking later about this. And ugreen.io/yes and or t.mi/ugreen. If you get by email, I will be sending you an email in a few hours, I think 3 or 4 hours or something, with the summary links. Okay. And on Telegram, I will be sending there as well. So you will see on the timeline on Telegram, we share more content there. So Telegram is a great channel for you to be related on what we are doing. Okay. Guys, I just talked about the website's not working, and there are people telling the website's not working. But okay, let's proceed. But I think most people understood, so I'm very thankful for everyone who joined. It's great to see everyone here. Follow us on Instagram, follow us in our channels, because we always bring new content for you. All right. Tomorrow is going to be a very important class. We are going to talk about wellness. We are going to talk about mental health. We are going to talk about movement, how we can movement more better inside the space. We are going to talk about nutrition. We are going to talk about thermal comfort, how we can increase thermal comfort. We are going to talk about controls that you can have. So lots of outstanding things in tomorrow's class. And the biggest class of all is going to be the 4th class, Sustainable Materials. It's going to be an insane class that Sam is going to talk 4 hours for you about sustainable materials. Sam is the material girl,
Endless
right?
material talk.
Yeah. Then we can just proceed to the 5th class, lighting design. So guys, sustainable design is important. As you can see, it can make a huge difference in your career. You can get better clients doing sustainable design. You can improve your projects. You can make better for other people. You can find this new motivation, right? We found a new motivation doing sustainable design. We started working on the real estate industry, right? Me, Sammy, and TC, and we understood that we needed to make a shift for a more motivational things in our lives. Since we had kids, we understood that it wasn't the best path, and sustainable is a very good path to make. And we are talking with people from all around the globe, and this is insane for us. This is really insane, and we just like to say thank you for everyone who made part of this dream that we had this dream 5 years ago, right, in 2016. We began in 2016 and 2016, and it's insane the result that we are achieving now 5 years later from people all around the globe. It's insane, and you are a big part of this. And I just want to say thank you for everyone who make this dream come true, right? If you are not here, we couldn't be talking about this. So you are a big part of this movement, and we want you to grow doing sustainable design. We want you to make better projects, get more results in your practice. And as you can see, beautiful is not enough. We need to go deeper, and we are going to show you the way here. All right. Another thing, in the 4th day, just an last notification. In the 4th day, we are going to open an opportunity, but only for people who are in the 4th day, because we want people who are really into sustainable design, not just getting to the 1st class, taking a look, oh, okay, it's not for me. No, people who are really into it. We are going to open a very cool opportunity in the 4th day of this event. All right. Yeah, I will be a better designer for the planet. Cool. All right.
Yes, guys, thank you so much. We are so grateful to have so many people interested, so many people that are new to us too. As yesterday we were sending messages, we understood so many people that are new, that didn't know part of our work. And but we also want to thank the people that have been following us for a while, and people that are students that have been in past events, and they keep coming back. And this is so meaningful to us, as the people that keep coming back. and keep contributing on a chat or contributing with us. We keep trying to bring to every event, to every class that we put together, new things, because there are so much that we can develop in the sustainable area. And we want to keep, breaking, these barriers that people have put in front of us, saying that sustainable is more expensive, sustainable is difficult, and and you can only achieve if you spend more money. We want to show you alternatives to look at sustainability with a different vision. And there's tons of things that you can do, working with passive design, working with just alternative materials, or perhaps thinking of the space differently. So there are different ways that you can impact with sustainability, and perhaps you won't achieve 100%, but we want you to achieve the most that you can, and show you these opportunities. And like I said, when people come back to our events, or when they come back to our classes, it shows us that they've seen something, and this gives us even more drive to keep going and to keep innovating and bringing more and more knowledge in this field for you guys. And I also want to say that we have not just new people, but and a recurrent student, but we also have family. I just found out that one of my family members is watching too, and she's in Germany. So I want to say hi to Jessica, who is here too.
All right. Just one other thing I want to
everyone.
know from you guys. Who is going to be tomorrow here? Tell me in the chat, please. I just want to know. I will be here, I think.
I'll be here.
All right. Let's see. Cool, man. Great to see.
I want to give two shout outs to two. One for Yeda, she told me she was watching as well, and another one for Monica Geller-Bing. I sent a summary for her yesterday, and I don't want to know if it's a fake. Monica Falula Geller-Bing. Thank you very much. You made me happy.
All right. So this is it for today, guys. Tomorrow is going to be even better. We try to make, I think, I don't know if people knew this, but acoustic was the content that people least wanted to know, because in our survey we put all 5 contents, and acoustic was the least that people wanted to know. So you guys are really ahead of lots of people with this class. You learned lots of good things, and
Warriors.
wellness is going to be amazing as well. We're going to see about water quality as well. It's going to be amazing for interior design. All right, guys. So this is it for today. Sleep well, wake up well, depending on the time zone you are. Have a good lunch. Have a good a dinner or a breakfast. We want you to be very healthy for tomorrow, because tomorrow are going to speak about wellness. All right. TC,
Okay.
last words.
Last words. Thank you very much. We know this is a hard class, acoustics, but you know the responsibility of being an interior designer, and we want you to be aware of it, to make a difference, and we hope to see you tomorrow.
Yes.
So,
did I improve it?
Sorry? What?
No, I just asked if I did improve my goodbye. So
okay, yeah, you did well today.
Okay. Yay.
So guys, we see you tomorrow. Let's go, man.
So, yeah. Sorry, I forgot again.
We do this.
Okay, tomorrow.
Fifth day will be rehearsed.
We see you tomorrow.
Sammy.
Okay, we can do. I start Sammy and TC, right? So we see you Sammy is the grandma here.
What am I
Always.
supposed to do? Am I supposed to do the
Just
second
do this. Just
Just
do
do this.
this. Yeah.
Yeah, but you are the second one. So, okay, we are going
Okay.
to do this. Okay, we see you. The Sammy says to and TC tomorrow, and we
Oh.
end.
Okay.
Okay. Go.
Okay. We see you
Two.
Tomorrow.